let's talk about bases other than E. Do things a little differently this time. I'm going to solve some problems and talk about the properties as we go. So here are some of the properties just to start off with. If you have some base a to the x that is equal to e to the ln a to the x, or log base a of x is equal to 1 over ln a of ln x, these are some properties. A not equal to 1. All the properties of bases other than natural logs hold true as the same one. The natural log and base log of any base of 1 is 0. Um, all these other things, as far as the addition or the bringing the exponent out front, all hold true, same as we did before. And this if and only if law, the one that talked about a to the x, if and only if x is equal to log base a to the y, this is true. Also, the fact that inverses, these two things, and ln sorry, a and log base a of the x are inverses. So if you apply either one of them to the other one, then you get the identity function x. Okay, again, here we go. These two things, a to the x and log a to the y, x equals log a to the y. These things are inverse functions. So they've already switched the x and the y, and that drives me nuts. I wish they just leave it. All right, so bases other than e, something we haven't seen, which is they started us off with it, so why not? So they talk about half-life. If 8 years is the half-life, then find out what the fraction is at 16. You just take a half and raise it to the t over 8 power. Whatever your half-life is, number comes down here. That gives you your equation. And then if you want to find out what t is 16, you just plug it in for t. And this is 1/2 squared, which is 1/4. Talking about evaluating without a calculator. Log of base 27 is 9. Log 9 base 27 equals some x. Find out what this is. Well, they use the property y equals a to the x if and only if x is equal to log a to the y. And you know what? I remember it this way. I just said take the base to the answer power, and that should equal the log. So 27 to the x power should equal 9. If you put them both in the same base, 27 is 3 cubed to the x power is equal to 3 squared. And now that's power to a power, you multiply exponents. That's 3 to 3x equals 3 squared, or 3x must equal 2, x is 2/3. Same thing over here. Log 3, log 1/9 base 3 is equal to -2. What does it mean? Again, base to the answer is equal to the log number here. 3 to the -2 is equal to 9. Put the thing into, if you need to solve this anyway, put the 9 into base 3 and you'll roll from there. 49 to the 1/2 power is equal to 7. What does that mean? Again, just run to the fact that this should mean base, this should mean answer, this should mean log number. So that goes in place of the log, this goes in place of the base, and 1/2 goes in place of the answer. Again, I know that's not quite what the book has, but it seemed easier for me to remember it that way. If we want to sketch a graph for any of these, just make a table and plug in some numbers and see what makes sense. But this was pretty easy to do, and I thought it looked like a pair of Bola Payton. If you're going for solving for x, same idea that we've done before. Base to the answer equals the log number, so 3 to the x is equal to 1 over 81. Pop them in the same base. 3 to the x is equal to 3 to the -4, x is -4. Same here, base to the answer is equal to log number. B to the 3 is equal to 27. You can pop them in the same base. We could have just took the cube root of both sides. I popped them into the same exponent, and then I understood that the bases would have to be the same. Something a little more difficult, we're going to use the fact that that 5 to the x and log base 5 of x are inverses. So if you have 5 to the 6x is equal to 8320, and honestly, could you do this the other way that we just talked about too? I suppose you could, but let's talk about it for a second. So I take log base 5 of this side, and I take log base 5 of the other side. These two cancels out, leaves you with 6x is equal to log base 5 of 8320. Now you're going, I have no clue how to calculate the log base 5 of 8320. As you can see, I went ahead and divided by 6, cleaned it up a little bit here, but let's talk about this. There is such a thing that says log base a of x is equal to 1 over ln a times ln x. So in this particular case, log base 5 of 8320 is ln 8320 over ln 5. And I can use this to now put it into calculator in terms of natural logs. So we use the inverses for the first piece, and then we use the fact that log base a of x is equal to 1 over ln a times ln x. All right. Last but not least, 32 here, log base 10 of t minus 3 is equal to 2.6. Again, I used base to the answer is equal to the log number. So I just went 10 to the 2.6 is equal to t minus 3. I added 3 to both sides, put it in my calculator, no problemo. All right. So that'll be the first set. We might do something else in class, but there's an idea of how to get into exponents other than e, bases other than e.